Yeah, greetings. We're going to get started with the pre-lunch session. The first talk that we have coming up is entitled "Can ISPs and P2P Work Together?" and it's Laird Popkin from Pando Networks and Doug Pasko from Verizon.
We're going to use these mics.
Okay.
Go ahead, sir.
Hi. So P4P is a working group with ISPs and P2P companies trying to work together under the DCIA. The DCIA is the Distributed Computing Industry Association, which is the P2P trade group, also with media companies and internet service providers now participating.
Doug Pasko from Verizon. Part of why we're here is to let you know what we've been up to in the DCIA, and it's sort of at the end of this, solicit sort of more participation from the audience here and folks representing ISP community in the room.
So we're seeing the P2P market maturing, and we'll be talking about kind of how the market is maturing, and then about the P4P working group. So digital content delivery is where things are heading, and P2P in particular, content people are very excited about as a disruptive market opportunity to deliver very high quality content to their customers.
And we're already seeing a lot of examples of this. I mean, I don't know how many of you were tracking what the BBC did over in the UK, and now you got NBC Direct is rolling out some production quality peer-to-peer traffic. So the sort of everyone knows the history in the nefarious illegal world, but it's rapidly we're seeing huge changes as the production folks are getting involved and seeing this as a viable platform for distribution of media, especially the high-def media, which gets pretty expensive to deliver online.
So the P2P market has been maturing from kind of a rogue technology with standalone applications to P2P being an extension of the content delivery infrastructure in partnerships with CDNs and ISPs. And so the major content companies and CDN players are now working with P2P companies. So really the perception in those worlds has evolved over the last year or two.
So this is a slide I'm sure you've all probably seen from CacheLogic. It's a little bit dated. Actually, I think some of the percentages have shifted back a little bit in favor of web with the explosion of YouTube, but that is in no way really diminished the explosive growth of peer-to-peer, especially with, again, the media companies getting involved with high-def video. It doesn't take much high-def video to skew that back in the other direction.
So there's been an ongoing wrestling match between the ISPs and the P2P companies where the ISPs can respond to P2P traffic by upgrading infrastructure, caching, terminating user connectivity, rate limiting, various other tactics, and the P2P companies can respond with encryption and port hopping and a whole variety of countermeasures, leading to kind of a back and forth, which really is kind of a waste of effort on both sides, I believe. So really a lose-lose.
Yeah, and pretty expensive for the ISPs. I'm sure you all know how expensive it is to implement some of these measures. So fundamentally, I mean, obviously we're seeing this huge growth of peer-to-peer traffic on our infrastructures. And the things we used to do to manage traffic don't really apply quite as well to the peer-to-peer world. Things don't flow in the way they generally used to. The client-server model is sort of thrown out the window. And it's just not effective to try and manage peer-to-peer in that way. It's very dynamic and moves all over the place. So what we're working on in the DCIA is, it's called the P4P working group, but we're looking for other mechanisms that we can use so the ISP community can still work together with the peer-to-peer community and implement some of the same sort of control mechanisms that we've had before in the traditional model into the peer-to-peer space. And one of the key pivots there is, making the tracker infrastructure smarter, and we'll get to how we're doing that.
I don't know if you want to say about that, but so that's P4P.
So believe it or not, partnership and peer-to-peer companies in the same in the same work.
Okay, so this is the P4P working group is co-chaired by myself at Pando, Doug at Verizon. It's based on research from Yale, and it's hosted by the Distributed Computing Industry Association. These companies are in the core working group, and then we also have a number of companies that are observers. And so the point of these slides is to show that there's broad participation by the P2P companies and network-related companies.
Yep.
So the goal is to design a framework to allow the ISPs and the P2P to coordinate to guide the connections in order to improve the throughput for P2P users and manage link utilization, which do you want to talk about?
Yeah, I mean, one of the easiest things here is that the peer-to-peer guys, even when they're trying, they don't have access to our topology information. They don't know how our networks are laid out, how things are interconnected. They can make some sort of guesses. And then even if you can accomplish those guesses and they're fairly accurate, you also don't know the difference between business policies. There's peering relationships versus transit relationships, fiber that's inexpensive, fiber that's more expensive to expand capacity on. So we're kind of see if we can blend some of the business requirements in with the technology so we can get a beneficial result. The short version of that is reduction in average hop count is the huge win, and we'll have some metrics we'll show you on that one. So in general, again, this is a cooperative effort. We're trying to look for a solution that's an industry solution versus something that ends up being a regulatory solution. And quite honestly, with the hints of huge amounts of high-def traffic coming out in the peer-to-peer space, let's try and solve some of these problems before we have to cope with these problems. That's not necessarily the position we all want to be in. And also on the flip side, if we can kind of drive the evolution as the ISP community working with the peer-to-peer community to get carrier-grade solutions, that sort of blows the doors wide open on things that we might use the technology for ourselves, for our own services. And I like to say, what if the fastest path from A to B is P2P?
And so from the P2P application perspective, a big win is a smarter network utilization gives much better performance for our users. And as a more indirect benefit is that by being more efficient, we have less impact on the ISP's infrastructures, which gives them less incentive to manage the P2P traffic, which we think long-term is potentially a big challenge in the P2P business. So this is a picture at kind of a high level of the data flow of a traditional CDN. Data is delivered from the CDN's infrastructure down through the ISP's infrastructure down to the users. There's lots of data transiting in large volumes, but it's a predictable data flow. There's P2P, which is kind of random connections from random locations, a lot coming from outside the infrastructure, some within the infrastructure. But because it's unguided, it's kind of random in all directions, which makes it hard to manage and not particularly efficient from an ISP perspective. P2P with P4P, knowledge of the ISP's infrastructure, can be guided so that you can form connections on local loops, for example, that don't consume any resources up from there, and so on at the regional and transit level. So it can vastly reduce the data delivered from the general internet down to the users and also make it a more manageable flow for the ISPs.
Yeah, I mean, a lot of this is traditional looking network management solutions, but to get these in the peer-to-peer space, you have to sort of step out of the network up into the application layer and work up there before the choice is made of which peer to talk to. Because after the choice is made, all we can do is manage the traffic getting from point A to point B as fast as possible. This is, okay, let's take our network management principles and change B. Help make a better choice for which B to talk to and get the same savings we do. Okay, so I think we talked a little bit about a lot of this, but more specifically here, what we're talking about is sort of a sharing of topology data in an abstract way. This isn't something that we're saying, oh, let's just give you all of our router configs and capacity planning layouts and such. This is let's share the information that is useful, but it's essentially a sanitized, generalized set of information. So it's not purely like I have 4 circuits over here and 3 routers over there. It's sort of summarized up. A big part of that is the privacy protection. Anything we're talking about here from the ISP community, I don't think any of us are going to want to do something that reveals too much about our customers and our users and kind of calls them out, or worse, put too much data out there that somehow we've created a security threat for ourselves. Someone else gets the data that we don't want to have the data. So
yeah, and from the P2P perspective, some of the challenges are that it needs to be highly scalable because the P2P networks are very large and diverse, and flexible. Whatever the approach is that we resolved needs to be flexible enough to apply to a wide range of P2P architectures because there are many different kinds of peer-to-peer networks with many different characteristics, such as whether they're coordinated by trackers or they're trackerless. And it needs to be relatively easy to implement because everybody here and all the P2P companies have lots of things to do in life. So it needs to be very pragmatic, easy to implement.
Yeah.
approach.
And obviously, again, we're coming to this forum looking for more participation. This is something we want to drive to be an open standard. And just mentioning the low-hanging fruit, this is ISPs choose to share some information that we haven't shared before, which pretty much costs us $0, and you'll see how much of a capacity savings we'll get out of that. But again, $0 for what we're talking about the benefits being.
Right. So high-level picture of the P4P architecture. The peer-to-peer clients talk to what's called the P tracker, or say the tracker in a BitTorrent swarm, for example, to figure out who to talk to. The BitTorrent tracker talks to what we're calling the I tracker, which is the ISP's information, in order to provide guidance back about which peers to connect to which, so that then the peers get told to connect to nearby peers. So fairly simple integration point, and we've implemented an integration. It took days, not months. So if you look at the math of it, it's a joint optimization problem where you're trying to simultaneously minimize the network utilization by the P2P, particularly the backbone link level utilization, and you're trying to maximize throughput for download delivery. So that ends up driving the math of the situation.
Yeah, and in general, again, at the end of this, the customer gets a better experience versus having something slowed down or taken away from them that they're already using. So it's sort of, we get savings, but the customer also gets to be happier at the same time. So that's a win-win on both sides.
So the data that in the first pass at this we're exchanging is that the ISPs give network maps into an eye tracker, and the eye tracker provides some abstracted, called a weight matrix or cost matrix of connections between locations that does not give out topology information. So for example, if this is kind of a hypothetical map of an ISP where POP 1, 2, 3, 4, 5, 6 are interconnected with connections with those percentages are kind of an abstract measure of how much you want traffic to go along those paths. And that gets processed into a matrix that says if you're in POP 1, then X% of the time you want to connect to users in these other POPs because they're more or less connected. And that's the abstracted guidance that the peer-to-peer network gets in order to say, for example, that if somebody's in POP 1, they should connect to people in POP 2 before they connect to people in POP 4 or 5 because they're far away. So we ran some simulations modeling the BitTorrent protocol and using network topology provided by Verizon and Telefonica. And the results so far.
Yeah, this is where it gets really interesting. Again, I want to emphasize $0 for ISP to sort of contribute to this. And if you look at Telefonica and Verizon, the before and after, this is, again, Yale modeling results, but the Yale research guys provide us these nice charts that show a huge reduction in the average hop count, which we all know every time we have to carry a piece of traffic across a given link, it costs more for router interfaces, costs more for circuits. So you're dropping the hop count at least by half with a lot of this peer-to-peer traffic. So that's literally that same traffic gets to the user that he wanted, but used half the network infrastructure to do it. Now there's a little difference between, you're reducing more of the long haul than less of the regional, but that's still a huge amount of traffic that you don't have to carry as far as you had to before. So again, translates into direct dollar savings just to share this sort of information and make the applications a little bit smarter.
And from the P2P perspective, the simulations yield good delivery results or or shorter download times. So the bottom line in these charts is the time to completion. So we're seeing things like a 50% or even 100%, a 50% to halving of the download times. So what that means is that users get data more predictably and more rapidly while also at lower cost to the ISPs.
And this is all without any sort of caching infrastructure that, the caching folks have been involved, but this is just purely, making better decisions. The caching infrastructure is, we're making cache discovery as part of the standard as well, just further increases this, the bandwidth savings and the performance increase, so.
Exactly. So if you're interested, the P4P working group is free to join. There are monthly meetings or conference calls. There's an email list. And there's a field test now underway, so we'll have results from that shortly. And so what we're working on is we're evaluating the design through experiments such as this field test, and there'll be an ongoing series of field tests. Then the next steps are to more formalize the process and work out standardized protocols. So going beyond the proof of concept that validates the basic approach to making a more formal standard. And then driving forward adoption of that and serving as an ongoing forum for ISPs and P2P networks to coordinate these sorts of issues.
So that's pretty much it. I would welcome questions, on what we're doing, how we're doing it.
They're all on IRC.
Oh, I can't read the IRC up here. You have to ask on a mic.
Yeah, hi. Is this on? Yeah.
Yep.
I'm Paul Francis from Cornell. So I was curious. I mean, you have this interface, right, where you have this matrix or something, and there's this mathematical thing that happens that probably neither you nor I understand. I was wondering why you don't have for instance, a simpler interface where, I don't know, the peer simply says, here's some IP addresses I want to potentially contact with, and the ISP returns the thing that says, I give this one weight X and this one weight Y, and then the peer can decide, based on whatever, which one it's going to use. I mean, I can imagine much simpler interfaces. Sure. And so I'm curious as to why you came up with the one you did.
Yale's original research actually had an approach like that, but what we ran into was the communication volume between the peer-to-peer networks tracker and the eye tracker was very high, because you need to have one query per end user announcing in order to say, here's the list of, 1,500 IPs that are in this swarm, which 40 are the best, and then get back a recommendation specific to that person, because the next person who announces gets a different recommendation because they're in a different place. And that communication overhead was pretty rough. So we ended up moving the map into the peer-to-peer networks tracker so that it gets given this abstracted map, so it can map IPs to locations and then figure out who to connect to who as a local in-memory operation. Given that we're seeing thousands of announces a second or tens of thousands of announces a second, we just couldn't sustain that kind of communication.
Yeah, is that earlier stuff documented anywhere? Because that's the sort of thing that's good to know, is to you sort of document what you ended up with, but not really how you got to.
Yeah, and I should also say that the specific architecture that's here is the architecture of this proof of concept test, but it's an open dialogue, and if ultimately we end up with a different architecture that solves the problems better, we're very open to that. This is our goal right now is just to validate the basic idea that localizing data transfers improves performance and saves money, which seems like it ought to be true. But the mechanics of how we do it, we're not particularly tied to this proposal. We're very open to proposals from Cornell, or Berkeley, Washington University, et cetera, where there are a number of universities involved in this effort.
Yeah, pretty much we've got the proof of concept, we're proving it out, and then we're essentially at the beginning stages of starting a standard work, in the formal sense.
Okay, no, it's cool stuff, so that's
cool.
Great.
Danny McPherson, I had a question, then I guess two questions actually. The first was, when you do that optimization, then it would seem to me you would have higher peak rates in the LAN or from the subscriber distribution side. And that's one of the larger issues from a peer-to-peer rate limiting perspective, that sort of thing. So, and some of the data I've looked at shows that topologically, like inter-domain traffic, peer-to-peer isn't a very significant part of that. Maybe 1 to 4% maybe of traffic inter-domain on networks is peer-to-peer traffic, as opposed to localized traffic, which could be 80, 90, 95%. And I know that data is not published, so it's not really. But the point of that is, are you solving the wrong problem?
I would love that data to be true. I have some different data we've worked from that says it's very much a huge percentage of peer-to-peer traffic ends up crossing a peering link or a transit link of some kind. So we can definitely talk offline about the data you've got.
Okay, no, sure.
You're absolutely right. This could encourage higher peak times for the end users, but that brings up a point that we didn't make. This is purely an optimization sort of standard exercise. Any other policies or procedures an ISP might be trying to implement is completely separate, and this in no way invalidates anything like that. I mean, if someone was trying to to do some sort of traffic management, you can still do those same things, but you might as well save that distance traveled.
I understand. I understand that piece.
Right.
It was the peak rate. And then my other question, I was kind of surprised I didn't see it in your slides anywhere, was the well-known net neutrality debate and what you guys might be doing from a technologist perspective to contribute some clue to that from that perspective, because I followed some of the some of the legal and regulatory and even the economic viewpoints on that, and there doesn't seem to be a lot of technology, and I think something like this could contribute positively to that.
This is definitely getting a lot of attention on that front as well, and quite frankly, this is sort of what the internet is supposed to do. It's an industry solution to an industry problem. It's one facet of a much bigger issue, but if we can sort of stem that curve that looks like it's a vertical line almost with bringing HD traffic onto the net. If we can make that more reasonable, then all of a sudden that changes the dynamic of what carriers need to do to manage their infrastructure. So we're trying to help with that, and there's many other ways to kind of crack that nut, but this is one thing that we can do that's so easy, low-hanging fruit if this gives us a benefit.
From an explicit sort of chartering or goals perspective, is that one of the things you guys is to provide some technical contributions to those sort of inputs, to be it the FCC or FTC or whatever?
Well, that's a more general DCIA function, and actually all the members of the DCIA help with that. We just recently sent in a paper to the FCC on some of the same topic. It's actually online to read from the DCIA. But being in the DCIA is like a really good vehicle to make sure everyone's voices get heard in that sort of discussion, and they're a great trade organization for that. So not to plug the DCIA, but it's been really good to operate in this stage under the DCIA umbrella.
Okay. Yeah. If you want to give us your card, we can email you the FCC submission that the DCIA sent.
Okay, very well. Thank you.
Uh-oh, it's Bill.
Hi, Bill Norton. Do the peer-to-peer protocols today try and infer any type of topological information, latency, ping types of tests, that kind of stuff?
Yeah, some networks try to, some don't.
Some try the reverse, actually.
So some of the P2P networks use random peer connections, like kind of your generic BitTorrent sort of approach. Some of them try to reverse engineer some sort of network structure based on trace routes or ping times and things like that. And one of the major ones actually goes out of its way to connect cross ISPs whenever possible and avoid intra-ISP connections for reasons of their own. So there's a wide range of proprietary approaches to this. And one of the things about P4P is that it should be viewed as being an addition to all of the capabilities that P2P applications already have. Yeah. So if for a given ISP, we have really precise information that can help us make very good decisions about these connections, we'll do that. If we don't have that information, just speaking for Pando, if we don't have that information for an ISP, we'll try to do good things, but obviously less successfully and with less precision than if we have precise data from the ISP.
Yeah, I guess the one thought that came to my mind when I saw that matrix was, is there any motivations on the last mile ISP side that would make them want to look a whole lot less attractive from the rest of the world's perspective?
Oh, essentially use this sort of topology information to discourage peer-to-peer traffic on their network.
I don't want that stuff on my network, especially as seen from the outside, that kind of thing.
Actually, the initial responses have been sort of the reverse. There was a concern that doing this optimization might accidentally attract extra peer-to-peer traffic to my network than was originally intended. So it's a good balance. Like I think Laird was saying, it's more information when you had none or less to start with. It just sort of augments any of the protocols. I mean, the Verizon guys have been pretty good about their trace route stuff they talk about and sort of reverse mapping. But nothing that the peer-to-peer guys are doing with sort of reverse engineering the networks can possibly include any business information. And that's a huge component, especially the international ISPs and anyone who's not a tier 1 ISP. There's wide variance in how much things cost. They may have two connections to different ISPs, both at 5% utilization. One costs you money and one doesn't. So and being able to express that and be part of that communication process. I mean, part of the working group is as much education for the peer-to-peer community in general as it is supplying this information. I mean, the folks doing the off-net as much as possible algorithm, they didn't do it because they were evil. They did it because they thought that was somehow better. They thought there was a benefit to that. When it turns out, I'm like, stop taking money out of my pocket. Let's work on some optimization, sort of going the opposite direction. So.
So how are you thinking to distribute this data to the peer-to-peer applications? I mean, peer-to-peer clients doing like 200 new connections per second. That's going to be a lot of lookups. Are you going to feed every application with a BGP feed or something like that? What are your thoughts about how you distribute the data?
I'm not sure I heard the whole question there.
I'm sorry, how are you going to distribute the topology data with all information to the applications, to the clients?
For the P2P networks where there is something like a central tracker that coordinates who should talk to who, like BitTorrent, that tracker needs to get the map information, and it can use that to guide which peers it talks to who. The peers don't have to have that data. For the distributed peer-to-peer networks, that's a pretty good question, and I don't think we have a good answer yet. One of the proposed answers is that each peer asks the eye tracker for guidance, but that then creates a lot of load on the eye tracker, so I'm not sure that's practical. So I think that's an area where we have to do some research.
Okay.
Yeah, if you've got some ideas, I'd love to hear them.
Thank you.
I mean, just to sort of summarize a little bit of what was just said there, I mean, generally what you're going to end up seeing if every ISP participated in the standard, it's going to look sort of like an offline global IGP. You know, simplified data, but I mean, that's kind of what you're going to end up with at the end. So, you know, there's a lot more routing expertise that, you know, needs to be brought to the table on how to really do that efficiently. But effectively, you're creating a global IGP database for all the ISPs and the business rules of how they're interconnected and such. So it's definitely a challenge. But again, this is information sharing that gets us a benefit. So it's a lot cheaper than putting more boxes in and more circuits in. Oh, I think.
Another question? It looks like.
Someone asked a question? That's all right.
Hi, Jeff from Equinix. Just a quick question about security. What's going to stop somebody from getting onto a tracker box and accessing that map information and maybe changing the peer information so that all the peers will connect to one network or another network and potentially causing a DOS attack that's legitimate traffic. So from a network administrative standpoint, it could be problematic because it looks like legitimate traffic.
Yeah. From the P2P network side, we're viewing the P4P information as guidance, but it doesn't replace everything else we do. So if the P4P information tells us that all data on the planet comes from some poor guy in Taiwan, we'll still connect the way we do now, plus one poor guy in Taiwan. So it won't hurt us that much. We won't gain the benefits. We'll lose the kind of the performance and efficiency benefits, but we won't be any worse off than we are now, particularly except for one guy in Taiwan.
Yeah. And actually that goes to a little bit of like how we're going to assemble the data and share the data. I mean, we say open standard, but the reality is, I mean, the ISPs, ourselves included, are going to want to have sort of some rules governing how their data is shared to the outside world. And I don't know that it's going to be just, it's on an FTP site, go download the topology database. It's most likely going to be some sort of entity that the peer-to-peer folks may have a relationship with. So it's not just, it's freely available, but you have to sort of register or become, accept how you're supposed to use the data. So, but that's something to work out. That's something we have to figure out how to resolve, because you're absolutely right. There's a security issue there, and you can create some sort of problem with it. We've not done our job well.
Thanks.